Hey everybody, happy Wednesday or Thursday if you are watching this on Thursday, or Friday or Saturday or Sunday if you're watching this behind. And if you are behind, it's alright. The beauty of these lessons, you can get caught up. Anyway, yesterday we graphed a single inequality. Today we are going to graph a systems of inequalities. We're going to graph multiple equations at the same time. So suppose we had y was greater than 3 plus 2x. We'd graph that just like we'd graph any old inequality. We start at the y-intercept of 3. It goes up 2 over 1, up 2 over 1. We connect it with a dotted line or a dashed line depending on your vocabulary. I tend to say dotted line, but I tend to graph a dashed line. Silly Elliot. Okay, so I have a nice graph like that. And then let's see, I have, I'm not going to do the shade. No, I am going to do the shading. It says y is greater than, so I'm going to shade above. But instead of doing deep, dark shading, I'm going to do really light shading. Yeah, it looks like you guys can barely see it. So now let's get to graphing the second one. I have 2 over 3x minus 1, so I start off at -1, up 2 over 3, up 2 over 3. Connect the dots with a dotted line. No, wait, dotted, that's equal to solid line. So I graph with a solid line. All right, then where is our solution set? Oh, I haven't done my shading yet. So my first graph, it was shading above. So once again, go back, do a little bit more shading there. For the second graph, the shading was below. Now, where's the solution area, though? Because it's not where we do all the shading. Whenever you have two intersecting lines, there's kind of 4 different zones, quadrants, areas, whatever. 4 different areas, I'll say. And in 2 of those areas, we shaded, like let's say, like if I shaded above this line, and then let's say I shaded below this line. If you look in zones 2 and 4, those got single shading. Zone 3 didn't get any shading, yet zone 1 here got shading by both lines. And that's the solution area. So on one hand, I'm above this line, I'm below this line on the other hand, and this area right here is where the shading was overlapping. So that is my solution area. And what's the solution area mean? That means that if I took a coordinate that was in the solution area, such as -1, -2, -3, -4, -5, -6, -7, -1, -2, -3, -4, -5, -6, -7, -8. -7, -8 is in the shading region, which means this coordinate will get me a true statement if I were to plug that coordinate into either equation. So if I checked it out, -8 greater than 3 plus 2 times -7. -8 is greater than -14 plus 3 is -11. -8 is greater than -11. True. You can plug it into the second equation. -8 is less than or equal to 2 over 3 times -7 minus 1. Let's see, this is -14 thirds minus 3 thirds, so -17 thirds. -8 is less than or equal to -17 thirds, also a true statement. So a point that comes out of the solution area, if you plug them into both inequalities, you'll get a true statement. If you plugged a point from this one in, where it got single shaded, it would work for one equation but not both equations. This single shading over here would work for one equation but not both equations. This area over here that there's no shading, it wouldn't work for either equation. So this is kind of the standard systems of inequalities that you graphed when you were in Algebra 1. I have a couple more examples. They're going to get more complicated as we go along. Check this one out. I have 4 equations to graph at the same time. So I have y is less than or equal to 5 minus x, y is greater than or equal to 2x minus 10, x is greater than 0, and y is greater than 0. Now, you don't want to use shading on this because it's going to get really complicated. We are going to use shading, but at the very last step. So first, y is less than or equal to 5 minus x. 1, 2, 3, 4, 5. Down 1 to the right 1, down 1 to the right 1. Connect with a solid line. And then it says less than, which means shading is going to go less than under this graph. But instead of doing shading, I'm actually just going to draw some arrows to remind myself I should be shading below this graph. Next one, 2x minus 10. So negative 1, 2, 3, 4, 5, negative 6, 7, 8, 9, 10. Move this up so students can see. So I have negative 10 for the y-intercept and then up 2 to the right 1. And I connect the dots. La, 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 la. And then it says y is greater than or equal to 2x minus 10, which means I would shade above. So far, I'd be shading below this line and above this line. So if I was only shading based off of these two equations, my shaded area would be way over here. But they give me more constraints, more inequalities. They say x needs to be greater than 0, greater than or equal to 0. That is a vertical line along the x-axis, and you're going to shade to the numbers greater than 0, so you'd shade to the right of that. And then last but not least, you have this y is greater than or equal to 0. When I graph that, I get something like this, and it says greater than, so you'd shade above this horizontal line. Then you ask yourself, where's the solution area? So it's below this line, it's above this line, so that's all this stuff over here. But then it's to the right of the y-axis and above the x-axis. So the area that you're looking at in this particular case is just this triangle right here. This is the only time that I am filling in a solution area that works for all 4 of these inequalities. So this is my solution area, and it's the only place that it got shaded where it worked for all 4 equations. Interesting. All right, one more example for you. Example number 3. And this equation, and this one's actually kind of an advanced problem. I consider it an advanced problem because it has this parabola in there. Negative parentheses x minus 3 quantity squared plus 9. All right, let's get to graphing this. I'm going to actually graph the second equation first because this one's the weird one. So I have y is less than or equal to negative x minus 3 squared plus 9. This is a parabola. We've graphed these before. It has a vertex point at 3, 9. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then because there's a negative out front, you know that that parabola is going down. Let's see, I'm thinking, yeah, if I plug 0 into this equation, out pops 0, so we'll go through 0, which means it must be going through 6. Anyway, I have this downward facing parabola that goes something like this. I'm not trying to come up with a perfect parabola, just a general idea. Now, in previous problems, we shaded above or we shaded below, depending if it was greater than or less than. In this one, you have to do something different, and in this point, and this is called using a test point. So the test point, you need to use a point that is either guaranteed to be inside the parabola or guaranteed to be outside the parabola. I tend to do an inside point, and I know that this point right here, 1, 2, 3, 7, 3, 7 is definitely inside the parabola. And if I type this into this equation, 7 less than or equal to negative parentheses 3 minus 3 quantity squared plus 9, and then work this out. This ends up being 0. I get a 9 over there, so 7 less than or equal to 9. Then ask yourself, is this true or false? 7 is less than or equal to 9. That's true. The test point was inside the parabola. That means we're going to shade everywhere inside the parabola. If the test point that was inside the parabola would have been false, I would have shaded outside the parabola. So once again, pick a test point. Have that test point be inside the parabola. Run the test point through the equation. And if that test point ends up being true and it's inside, you shade inside. If the test point is inside and you get a false statement, you shade on the outside. If your test point was outside and it was true, you would shade on the outside. If your test point was outside but it was false, you would shade inside. So it's either going to work inside or outside the parabola. In this case, it was inside. All right. Next, y is less than or equal to 2x minus 4. So I have negative 4 up 2 over 1, up 2 over 1. Connect the dots with a solid line. And then it says y is less than that, so you'd shade below. So instead of shading, I'm going to draw those arrows that I mentioned earlier. Now there's more equations than just this, I believe. I have the exact same constraints as before, that x is greater than 0 and y is greater than 0, which essentially means that the answer could only be in the first quadrant when x is positive and y is positive. So I have this vertical line on this axis, shade this way. I have a horizontal line on the x-axis, shade that way. It's inside the parabola, yet below the line. So my solution area is all this stuff here. And that's my advanced example. Now, usually, these graphs, when you're given 3 or 4 inequalities, usually your graph would be contained like it is on this one. But sometimes, I'm going to do one more example, number 4. And let me show you an example where a graph might not be contained. Let's say I had y is greater than or equal to negative 3x plus 4. And I have y is greater than or equal to 2x minus 3. And let's keep the same thing. X needs to be greater than or equal to 0, and y needs to be greater than or equal to 0. All right. Number 4, draw x-axis, y-axis. And these are all linear. So just jump straight into it and start graphing. Graphy, graph, graphy. Let's see, negative 3x plus 4. So I start up at 4, I go down 3 over 1, down 3 over 1, connect with a solid line, and then I make a mental note that I'm going to be shading above that line. Done. Next, y is greater than or equal to 2x minus 3. 2x minus 3, up 2 over 1, up 2 over 1, up 2 over 1, connect with a solid line. And in this case, I'd shade above on this one as well. So right now, my solution area is this area here. And then it says x needs to be greater than 0. So I'd have that vertical line, and I could only shade to the numbers bigger than x is greater than or equal to 0. On my y-axis, it must be x or y is greater than or equal to 0. So I'd shade above. So it needs to be entirely within the first quadrant, yet above these two lines. So this is my solution area. Now this area over here on the right, that's not in my solution area. It's only these numbers like this. Entirely in the first quadrant. So note there's no shading right there. Okay, so that is graphing systems of inequality, several at the same time. Do well with these tonight on Thursday, because on Friday we're going to do these problems. We're going to do them with story problems, and that's going to be the last thing we need to learn this chapter. Anyway, have yourselves a great day, and I'll talk to you later. Bye-bye.